Howdy folks, welcome to lesson 11 of the CompTIA Network Plus course. Today we're going to be talking about IP address types. So this is a follow-up to the previous video which was just about, general IP version 4. And here we're going to go much deeper into the various kinds of IP address types you actually get. It's worth noting that you need to know each and every one of these if you plan on writing the exam. You need to be able to give an example of every IP address that's in this video. So in the exam, you can expect questions where they'll give you a name. They might, for example, say Loopback. Then you need to be able to identify from a list of IP addresses which one is a Loopback IP address. The other way they might potentially ask this in the exam is they'll give you an example of a random IP address and you need to go and identify from a list of names what kind of IP address that actually is. So they can go and ask it either or, vice versa. Now, with today's video, there's obviously going to be a list of things we're going to be talking about. Here is a list of the various kinds of IP addresses we're going to be covering today. First of all, guys, we're going to be covering what a static IP is and what a dynamic IP address is. That will then shortly be followed by the difference between a private IP address and a public IP address. Thirdly, we're going to be talking about Class A, Class B, and Class C IP addresses. That will be then followed by APIPA. What the heck is that? That's an actual IP address kind you get, by the way. And then the last one, yes, there's one more, guys, unfortunately, Loopback IP address. So there's a list of 5 items, but if you look closely, you'll see it's more than just 5. I mean, static and dynamic, that's 2. Private and public, that's 2. Class A, B, and C, that's 3. So this list is actually much longer than just 5 items. Alright, so yeah, this is going to be a bit of a longer video, guys, but we do need to cover this quite thoroughly to make sure you guys actually are able to answer these questions in the exam. So on that note, let's jump to it. Alright, here we are. We're going to start at the first one we had on our list, static IP and dynamic IP. So let's start at the first one. What is a static IP address? Well, guys, if you don't know, static IP is probably one of the most common kind of IP addresses you will get. It's one of the first ones you'll probably learn about. That is when you or someone like a user goes and configures an IP address manually. You configure it manually, and once you or someone configures it, it will not change until you or someone goes and changes it one day. I will show you guys a demo of this in just a moment. Now, it's also worth noting, just in case you don't know, a static IP is actually also known as a fixed IP address in some cases, or some people will even call this a manual IP address. So it's known as a static IP address, it's known as a fixed IP address, and in some rare cases, it's also known as a manual IP address because you configure it manually. Now, before I show you guys the demo of how and where you do a static IP, let's quickly move on to what a dynamic IP address is. What is a dynamic IP address? Now, that's kind of sort of the exact opposite of a static IP. A dynamic IP is a random IP address that your device will get every time it connects to a network. Now, believe it or not, most devices are actually set to dynamic by default. If you want your device to have a static IP, you would need to go and configure that manually. But if you don't configure anything on your machine, and you'll notice I'm saying device and machine because this is not limited to desktops and laptops. This can be on a server, it can be on a tablet, it can be a laptop, it can be pretty much anything these days. So on your device, whatever that might be, it's normally set to dynamic. That's the default setting. And when you connect that device, let's assume it's a desktop or a laptop, when you connect it to a network, it will automatically get an IP address, a random IP address. And this is issued randomly by something called the DHCP. Now, if you are in a home environment or a small office environment, the DHCP will normally be your router. Some people call it router, some people pronounce it as router. So in all routers, you've got something called DHCP built into it. It's normally turned on by default, and it will dish out a random IP address to your device as soon as you connect to that network. Now, in a medium to a large size company, the DHCP in a router, it's still there, but it's normally turned off by default. Well, maybe not by default, but someone went and turned it off because the IT technicians normally went and created their own DHCP on an actual server. They have an actual server on which they installed something called a role, and this would be the DHCP role. The benefits is, and this is probably why they do it, it gives them way more flexibility and functionality. They still have all the benefits that the router would have provided, except they've got much, much more than that. More on that later when we discuss DHCP on its own. So if you're curious about DHCP, there's going to be a whole lesson just about DHCP coming up later. So for now, in this video, we're just going to cover the various kinds of IP addresses you get. Now on to the demo. I'm going to move over to a virtual machine that I've got idling in the background just to show you guys what it looks like when you go and configure a static IP versus a dynamic IP address. So switching over to that virtual machine.
A few moments later.
Alright folks, here we are on that virtual machine of mine. I've already got Network and Sharing Center open for us. You might see this, you might not see this on your Windows 10 or 11. I've seen on some of the newer updates, you don't actually see Network and Sharing Center anymore. You've got to go to the new settings app. But that's besides the point. So what I want to show you is if you go into your network card, would it be an actual wire that's plugged into your machine or whether your machine is on wireless? If you go in there, Ethernet status, I'm going to go to Properties, IP version 4, Properties, and there you go. Let me just drag that out of the way. So that is the default setting at the moment of my virtual machine, which is going to be the same on most devices. It says obtain an IP address automatically, and believe it or not, that is called dynamic. So at the moment, this machine might very well not have an IP address, and as soon as I connect it to some sort of network, it's going to ask for one. Something we'll cover more on the DHCP lesson, but basically in a nutshell, as soon as you turn this machine on, assuming it's on a network, it's going to say, hello, is there a DHCP out there? And if there is one on a network, which there normally is, the DHCP is going to say, hello, how can I help you? Your machine or device is going to say, I need an IP address. The DHCP will then say, okay, cool, how about this one? It will offer one to your machine, a random one. Your machine will have a look at it and it's going to tell the DHCP, okay, cool, I will take it. And the DHCP will eventually issue that IP address to your machine. Now that sounds like a long procedure, but believe it or not, that all happens in a matter of less than a second. Happens like in a fraction of a second. Pretty cool, right? Now every day, your machine will generally have a randomly new IP address assigned to it. The old one expires and then you get a new one. So that is dynamic. You get a random IP address out of a pool of possible IP addresses. That pool is called the scope. So the administrators that configure the scope, they can determine how big this pool is, how many IP addresses it has, and from where does it start, and from where does it actually end. And then your machine will just get randomly out of that pool, assuming an IP address is actually still available. Now, if you were to go and click on the second option here, folks, the one that says use the following IP address, that is considered a static IP. So if I configure an IP address here now, it's going to stay on that. So we call that static, or as some people call it, fixed. You can type in whatever you want. Just make sure you stay within the range of that building that you're in. So I'm going to type in a random IP today, since this is just a demonstration. There we go. Random IP address. And as soon as you click on the second block, it's going to automatically detect what kind of IP address that is in the sense of class A, B, or C. Something we'll get to in just a moment. So mine detects that as class C, and I'm going to leave that at that for now. So I'm going to leave this idling in the background because I'm probably going to need this again later for one of the other IP addresses I need to explain. So for now, let's go back to the presentation. Alright, cool. So I think we've pretty much kind of sort of covered what a static IP is and what a dynamic IP address is. Moving on to the next topic, which was on our list, private IP and public IP addresses. Alright folks, so with regards to private IP and public IP addresses, starting with the first one, what is a private IP address? Now guys, a private IP address is one that you would have inside your home or inside your office building. And when it comes to what a public IP address is, that is something you'll have on the outside world when you go, for example, onto the internet. So as long as you are inside your home, your residence, or inside your office building, you have a private IP address. It does not matter whether you or someone manually assign that IP address, in other words, a static IP like we discussed previously, or whether you got it dynamically, in other words, automatically via DHCP inside the network. It doesn't matter whether it's static or dynamic, as long as it's inside your network, it's considered a private IP address. Now, if you would like to go to the outside world, you normally have to go through something like your router. And as soon as you go through your router onto the outside world, in other words, the internet for that matter, you would have what we call a public IP address. Your IP address actually changes. So inside your home, your office, each and every one of your devices will have its own unique private IP address. But as soon as everything in your home, your office goes online, you'll notice they all share the same public IP address. They all get shoved into the same pipeline, basically, so to speak, and they will all share the same public IP address. So you can actually go and check this out yourself. So if you know how to go and check your IP, your private IP inside your home, you can do that by typing in ipconfig into command prompt, if you know what command prompt is, and you'll see you got one type of IP address inside your home. And if you want to know what your public IP address is, there's many ways you can go and check that, but the quickest way would probably be to go to some place like Google, and you can literally just go and type in, what is my IP address? It'll show you what your public IP address is. You will notice that every device inside your home, your office, has its own private IP in command prompt, but when they go online, they all share the same public IP address. Now, to help put this into context, like earlier with static and dynamic, I showed you guys a bit of a demo. So I'm going to draw you guys a bit of a picture here, more or less. So I've got a router there for you guys. Humor me and go ooh and ah and pretend like it's a fancy router. Now, that router, I'm going to draw a line here, a hypothetical line down the middle here, to kind of symbolize the outside and the inside of your network. So there's a line down the middle of this router. Now, for the purpose of this demonstration, let's pretend the left side is the inside of your network. We can ignore the ports on that router. I know the right side, those 4 ports on the right, that's the port you would have inside your network, and the white one is the one you would have, going to the outside. So let's ignore that for a moment. Let's pretend the left here is the inside of your network. So that's inside your home or inside your office. On the right of this router, let's pretend that is the outside world. In other words, the internet. Now, inside your home or your office, what do we call that? We call that private. That is your private network on which you will have private IP addresses. On the outside of the network, we call that public. That's the public network on which you will have public IP addresses. Now on the left here, I'm going to add a couple of machines for you just to kind of really help reinforce all of this. So there is 1, 2, and 3 machines. I mean, I can obviously go and put more, but I'm going to run out of room here. And then I'm going to put a little globe here on the right to kind of symbolize the internet. I know it's not my best work, but there we go. Deal with it. I think that should, suffice to kind of imagine that's the internet. Now, on top of this router, I'm going to give you guys an IP address. You'll see there it's 192.168.0.1. Usually in most networks, the router will be .1. So that's going to be the first IP address in that network. So the router will be .1 in this scenario. And then the machines on the left, I'm going to make them .4, .5, and .6 respectively. And then as for the internet, I'm going to totally make up an IP address here on the right. I literally sucked that out of my thumb. There we go. So there's an IP address. That will be your public IP address. Now, if you look at these 3 machines on the left-hand side, guys, you can probably see they're .4, .5, and .6. Each of them has their own unique IP address inside this building, inside their home or inside their office. It's unique. It doesn't matter whether these IP addresses have been allocated statically or manually, as some might say, or it doesn't matter if they have been allocated dynamically via DHCP. The point is, these devices are inside your private network and they've got private IP addresses. Now, when these 3 devices want to go to the outside world, what device do they have to go through? They've got to go through your default gateway, which is your router. There we go. And from the router, they will go on out to the outside world, and there they will all share the same public IP address as long as they're on the same internet connection and inside the same building. So you can see that's what I mean by public and private IP addresses. So inside, on the left, you can see their inside IP addresses. In other words, they're private IPs. And as soon as they go to the outside world, they will all share the same public IP address. And that, folks, in a nutshell, is basically what private IPs and public IPs is. Now, inside these categories of private and public IPs. You actually get various kinds. So, I mean, if you look at private IP addresses, you get class A, B, and C, which is our next topic. So, with that note, let's move on to class A, B, and C addresses. Alright, so with regards to A, B, and C addresses, what determines the class of an IP address, you might ask? Well, guys, that is going to be the subnet mask. The IP address can be pretty much almost anything, but the subnet mask is what determines the IP address. So if you look at the picture there on the right, you can see I know it's currently set to dynamic, but when you type in an IP address, the IP address is not what determines your class, not really per se. Below the IP address, you'll see there's a second block that says subnet mask. Depending on what you type in there, that determines what class of IP address you're dealing with. That's the true thing that determines. So by default, if you type in something like 192.168 and you click on the second block, you'll see it says 222.55.0 because it detects that as a class C. Doesn't mean it has to be a class C. It's just normally a 192.168.0 is seen as class C. It doesn't mean it has to be. It can actually be any IP address. It can be class C, it can be class B, it can be class A. So it's not set in stone. So the subnet mask determines how many networks you've got and how big these networks are. So if it's 222.55.0 in the subnet mask, 222.55. something, in other words, it's normally going to be 0, but 222.55, that means you've got yourself a class C network. Class C consists of about 256 IP addresses, of which you can only use 254. You can never use the first IP address in the network or the last one. They're reserved for things like network address and broadcast address. Now you can go and make that network smaller. So if it's 222.55. something other than 0, if you change that 0 to something other than 0, you can basically go and subdivide that 256 IPs into smaller networks. So you'll have more networks, but you'll never have more than 256. So I can have 2 networks of 128 instead of 1 of 256. If you take 128 and you add another 128, what do you get? 256. Or you can have 4 networks of 64, or 8 networks of 32, or 16 of 16, and so on and so forth, until you eventually end up with 64 networks of 4 IP addresses each. That is class C. So the maximum amount of IPs you'll have in a class C network is 254 usable IP addresses. There's 256, of which only 254 are usable. So you can never connect more than 254 devices on such a network. Now that 222.55, guys, it could actually be 222.55. something. It does not have to be a 222.55. It can be a 222.55. something. A 222.55 means it's class B. Class B consists of approximately 16,000 odd IP addresses, a heck of a lot more than Class C. And if it's just 1255. something, that is Class A. Now, besides the subnet mask that determines your class, it's actually also the CIDR notation. So behind an IP address, you'll sometimes see a / followed by a number like /24. So it might be an IP address followed by a / and then maybe 24 or 25 or 26. That tells us what class of IP address we're dealing with, and it also tells us how many times it's been subdivided. So for example, if it's /24, that means it's a normal 222.55.0, so it's a class C, and you've got a full class C for yourself. If it's /25, that's also 222.55, but it's going to have a .128 at the back, which means you've got 2 networks of 128 respectively. So the CIDR notation is what determines how many times your network has been subdivided and also what class you have. If this confuses you, don't stress. There's going to be other videos about this where we're going to go into a lot more detail about that later. Now, a couple of examples of the different classes of IP addresses you get. You would remember earlier I told you that class C by default looks like 192.168.0. something. And when you type that into the block you see there on the right, guys, and you click on a subnet mask block, it will detect that as class C. And it's going to put in a 222.55.0. But it doesn't mean it has to be. You can go and change that 222.55 to a 222.55 or a single 255. That would make it a class B or a class A. So just because it detects that it's class C doesn't mean it has to be. But the exam tests you on what these IPs are by default. Not what they can be, what they are by default. Anyway, so let's give you guys a couple of examples of the different classes. So starting with class C, which is one of the more common ones, the example would be 192.168.0 dot something. The last octet can be something else. So in class C, the subnet mask is 22255 dot something. The first three octets of everybody's IP address needs to be the same for them to be on the same network. So in the exam, if they ask you to identify a class C IP address, look for the one that looks like 192.168.0. In real life, it can actually be any IP address, but by default, it's a 192.168.0. So if you were to go and type that into your IP address block, the one you see there on the right, and you were to go and click on a subnet mask block, you're going to see it detects it as a class C. It's going to type in, or it's going to auto-populate that subnet mask for you for 22255.0. As for class B, that would normally by default be a 172.16.something.something. So only the first two digits, the first two octets of everybody's IP address needs to be the same for them to be on the same network. Obviously, that consists of way more IP addresses. It's like 16,000 odd IP addresses now. And that subnet mask would be a 2255.something.something. So if you were to go to that little block you see on the right and you type in 172.16.something.something and you click on a subnet mask block, you're going to see it's going to auto-populate it with a 2255 for you, because by default it sees it as a class B. Lastly, with regards to class A, that would be a 10.something.something.something. So in the block on the right, if you were to type in 10.something.something.something and you click on a subnet mask block, it will detect that as class A. So you would only see 1255 followed by 3 zeros, guys. So to put this into perspective, with regards to class C, if you look on the right, I'm going to populate it for you guys. So there is what it would look like. So as soon as you type in 192.168.0.something, I typed in 110 there, and you click on a subnet block, it will detect that as a 22255.0, which is a class C. Doesn't mean it has to be, like I said, you can change that to a 2255 or a single 255. You have the ability to go and change that. But by default, it's seen as class C. So if you need to give an example for class C IP in the exam, look for the one that's 192.168.0. Or if they give you a 192.168.0 and they ask you to identify what class of IP address that is, it's class C. They want to know the default. They don't want to know what it could be. They want to know what the default is. As for class B, folks, keeping your eye on the block on the right, I'm going to change the IP address. There we go. Now it's a 172.16.something.something. So that's something I made 0.10, not that it matters. And if you were to click on a subnet mask block, it would detect that as a class B by default, which is just two 255s followed by 2 zeros. You can change that once again, but by default, it would be seen as class B. So in the exam, if they ask you to identify class B IP address, please choose the one that says 172.16.something.something. Or if they give you 172.16 and they ask you what class of IP that is, it's class B. Moving on to the last one, guys, class A. Keeping an eye on the block again. You'll see now it changed to a 10.something.something.something. That by default will be detected as a class A. And if you click on the subnet mask block, it'll detect that as a class A IP. And of course, yes, you can go and change it. So in the exam, if they ask you to identify a class A IP address, look for something that starts with 10. That will probably be your class A. Or if they give you an IP that starts with 10, that's probably class A. Alrighty, I think you guys get the picture. So let's move on to the next type of IP address we get, APIPA. Now, APIPA is actually short for something, guys. So what is APIPA? Let's start with what it stands for. It stands for Automatic Private IP Addressing. Try saying that 5 times fast. Now, nobody calls it by that big name because it's just too big. There's no way you're going to remember that. So everybody just knows this and calls it APIPA. That's what it is. Now, what does it actually do? Well, guys, it allows a DHCP client to automatically configure an IP address and subnet mask when a DHCP server is not available. So on that note, this does not work if you've got a static IP or a fixed IP address. In other words, if you go and manually configure an IP address, it's not going to change. And in that situation, APIPA does not apply. But if you've got a dynamic IP address, or if you're about to get a dynamic IP address, If you're unable to get one for some reason, let's say the network cable is unplugged, you're disconnected from the Wi-Fi, your signal is too weak, the DHCP is offline, or it ran out of IP addresses, whatever. The point is, if you're unable to get an IP address, if you set on dynamic, your machine would have what we call a APIPA. A APIPA is basically a placeholder, if I have to put it into a nutshell. It's not really what it is, but think of it as a bookmark or a placeholder until you are able to get yourself an IP address. So your machine would normally have one, but if it's unable to get one dynamically for whatever reason, it could be for any reason, you would have yourself an APIPA. So if you ever go check your IP address on your machine or a client's machine and you see they've got an APIPA IP address, it tells you that technically, they don't have an IP address. And it's up to you to figure out now why that might be. Now you're probably wondering by now, what does an APIPA IP address look like? Well, folks, let me quickly clear this up. So if you look at this little window we had earlier, this one here, you can see I am currently on a setting that says obtain an IP address automatically. So that's dynamic. So if you're on that setting and you're unable to get an IP address, you've got yourself a APIPA. Now getting back to what it would actually look like, let me switch over to a bit of a screenshot for you guys. There is a screenshot I took on my own machine. So you can see there my machine says burning ice. So I did that on my own laptop. And in that command prompt window, I literally just went and typed in the command ipconfig. If you type that command into command prompt on any machine, it'll show you that machine's basic network configuration. It'll show you the IP address, the subnet mask, and the default gateway if there is one. If you look at the IP address there, under auto configuration, it says 169.254.something.something. Whenever you see a 169.254, folks, that is a APIPA. So if they give you an exam, an IP address that starts with 169.254, and they ask you what kind of IP address this is, it's a APIPA. Or if they ask you which one of the following IP addresses is an example of a APIPA, and then they will maybe give you like 4 IP addresses or more possibly, look for the one that starts with 169.254. It doesn't matter what the last 2 octets is, as long as the first 2 octets starts with 169.254, it is considered a APIPA. It's not an IP address, it's a placeholder of sorts until you're able to get yourself an IP address. It's to tell you you technically don't have an IP address. That's what a APIPA is, folks. Alright, let's move on to the last type of IP address we get. Wow, this video is way longer than the other ones. I was trying to keep it as short as possible, but let's face it, we knew it was going to be long when we started this video. So the last one is Loopback IP Address. Now the name should kind of sort of tell you what you need to know. So, what is a Loopback IP address, you ask? Well, folks, a Loopback IP address is a special IP address. It's 127.0.0.1. It is reserved by Internik for use in testing network cards. It's not going to have any other variations. It will always be 127.0.0.1. That is a special kind of IP address we use. We go and ping that IP address, and it allows us to test our TCP IP stack. It allows us to check if our network card is working and if your network settings are correct. So you're basically pinging yourself. So when you do a ping, for those of you that know what a ping is, you normally send packets of data to another device, a remote device, and if your configuration is correct and everything is correct, that device would send all 4 packets of data back. Now, when you do a loopback ping, you do the exact same way. You're going to go type in the ping command into command prompt, followed by space, followed by that IP address, which is 127.0.0.1, and it's going to send 4 packets of data, just like a normal ping, except it doesn't actually leave your machine, believe it or not. It goes straight back to your own network card. It's to test your own network card and your own TCP IP stack. So if you suspect there's something wrong with your own card or your own TCP IP stack, you can go do a loopback ping, and if you get 4 replies, then at least you know your own card is in working condition. Now, before we conclude this video, if you're wondering what it actually looks like when you go and run this command, here's a bit of a screenshot for you guys where I actually ran the command. So in command prompt, you go type in ping, like you would normally go and do. So that's if you want to go and ping a remote machine, a remote server, or a website or something. And then normally after the ping, you would type a space, and then the remote machine's IP address or its name, or the website's name or IP address. And in this case, I'm not doing any of that. I'm typing ping, followed by space, and then that loopback IP, which is 127.0.0.1. It's going to send 4 packets of data, but it never actually leaves my machine. it's going in a loop back to my own machine to test my own machine's into card and TCP IP stack. So there we go. 4 replies. Mine into card seems to be working according to that screenshot. Alright folks, and that is a loopback IP address in a nutshell. Now with that, we are actually done with this video, so before you guys disappear on me, I really hope you guys have learned something in this video, because this video is quite long. So if you feel like you've learned something, do your homie here a favor and give this video a like. It does help me in the channel out when you do that. If you would like to know when lesson 12 goes live, because it's just going to get more interesting the further we go, maybe consider subscribing, otherwise you might miss that. And on that note, guys, thank you to every one of you guys that's been sponsoring the channel, supporting the channel. If that thanks button is available below the video in your country, to those of you that's been clicking on that, thank you very much. To those of you buying coffee and milkshake from me, and if anybody else wants to support the channel, you can find that information in the video description down below. You can buy a coffee or a milkshake, you can make a donation to PayPal. Heck, you can go and join my Patreon ship if you want to. You can become a Patreon. There's different levels you guys can choose from. And if you want to go make a PayPal donation or become a Patreon, your name can actually be displayed at the end of the video. That's optional though. It doesn't have to be. I would normally ask you if you want to have your name displayed at the end of the video. So yeah, if you feel interested in having your name displayed at the end of the video, maybe go make a donation. Otherwise, guys, thank you very much for your support. Here's a list of the Patreon supporters at the moment. Thank you very much, guys. Here's a list of the PayPal supporters. Thank you very much. And then lastly, what I normally mention is the channel does have a Discord server for those of you that don't know. If you would like to join that Discord server, the link is the very last link in the video description. So if you go in the video description, way at the bottom, there is the link to the Discord server. There you'll find myself along with many other people and lots of useful resources. If you're looking for extra resources that might not be on YouTube, you might potentially be able to find it there. Just hook me up or just shout out to me and let's see, maybe I can help you. Alright guys, I'll see you guys in lesson 12.